All right, so now we're talking about scientific notation, and we're going to use all we've learned so far in sections 1, 2, and 3 of chapter 5 to help us understand scientific notation a little better. So, writing in scientific notation looks like this: 3.2 times 10 to some power. So, something times 10 to a power. Standard notation is how you and I write numbers most of the time. So let's look at writing this using standard notation. So if we're going from scientific notation to standard notation. All right, so move it up a little bit. A couple of things we need to know when we're doing that. First thing is, if it's a negative exponent, we're going to move the decimal to the left. If it's a positive exponent, then we're going to move the decimal to the right. So in the case of this example right here, it's a negative exponent. It's a negative exponent, so we move the decimal to the left. So the decimal's here. It's negative 2. I move it 2 to the left, and everything that leaves a blank, you put a 0. So I get 0.034. So let's look at another example. In this case, we're looking at a positive exponent. A positive exponent tells me to move the decimal to the right. Now, what I like to do when I have this situation, I like to rewrite my problem, giving myself a little bit of room because I know I've got to move my decimal to the right. So I'm going to move it 1, 2, 3, 4 places, and every little bump with nothing in it gets a 0. So my final answer is 45800. The decimal is here, but we don't usually write the decimal. Another one with a negative exponent. So it's a negative 3. Negative exponent tells me to move the decimal to the left. I'm going to move it 3 to the left. The negative says move left. 1, 2, 3. Add your zeros in. So we 0.00125. So we're going to be going from standard notation to scientific notation. And when we're going from standard notation to scientific notation, we are told what to do based on how far we move the decimal. So if we move the decimal to the left, it means it's going to be a positive exponent. If we move it to the right, then we know it means it's going to have a negative exponent. In scientific notation, if we go back to our first notes, every time you see scientific notation, it's going to be a single number, not a 0, other than a 0, then a decimal, and every other number behind times 10 to the 5th. So if I'm going to write 700,000 as in scientific notation, I know I need 7, and you can either write it 7 or 7.0. We need to put the decimal here times 10 to some power. The decimal was here. We're moving it to the left. 1, 2, 3, 4, 5. And because we moved it to the left, we get a positive exponent, which is the 5. Oops, sorry about that. All right. In this case, I know I need a non-zero number, and then the rest goes behind the decimal. 10 to some power. I'm moving the decimal 1, 2, 3 to the right. So if I'm moving the decimal to the right, it means it's a negative exponent, so it's negative 3. So let's look at an example or two. Again, I'm writing from standard to scientific, so I know I need to have a non-zero number up front, then the decimal, and then the rest of the numbers times 10 to some power. I'm going to move the decimal to the right one place. That's where I have it. I moved it to the right. If I'm moving to the right, I know I need a negative exponent. I moved it 1 to the right, so it's negative 1. Again, I know I need a non-zero number in front. then everything else behind. You don't need to write these zeros. If you want to, you can. Times 10. So now I need to figure out 10 to what power? The decimal is here, even though I don't see it. I'm going to be moving it 1, 2, 3, 4, 5 places to get it here. If I've moved it to the left, that means positive exponent. Now, let's look at multiplying and dividing with scientific notation. So if we're looking at scientific notation, and first we're going to talk about multiplying. This is where we're going to use the rest of this chapter so far to help us make it easier. Just like in section 3 when we were multiplying monomials, we're going to collect the things that are similar. So we have 3.0 and 4.1. They are the plain numbers. Put them together. Put the tens together. So 10 to the 5th times 10 to the negative 3rd. We use the math and we do the multiplication. 3 times 4.1. If you're not sure how to do that, it's been a while since you've multiplied decimals. Put it over here. 4.1 times 3.0. You can drop the 0.0. 3 times 1 is 3. 4 times 3 is 12. There's one number behind the decimal, so I finish with one number behind the decimal. So 12.3 times 10 to some power. I have two bases with two exponents. I add the exponents. 5 plus negative 3. Well, that's the same thing as 5 minus 3, which is 2. Now, the problem we have with this is it's still not in scientific notation. Scientific notation, we need a number in front of the decimal, a non-zero number, and then everything else is left behind it. So I need to move my decimal 1 to the left. So I get 1.23 times 10 to some power. I moved my decimal 1 to the left. And if we go back to our notes that we just finished, when we move our decimal 1 to the left, actually it's right here, we move it 1. When we move to the left, it's a positive exponent. So if I move this to the left 1, I'm adding on that 1 exponent. So I get 10 to the 3rd power. Let's look at division. Again, putting the like things together, put the numbers and the tens together. So 9.0 divided by 3.0 and 10 to the 8th power divided by 10 to the 2nd power. 9 divided by 3 is 3 times 10. Remember, two bases, two exponents, we subtract. 8 minus 2 is 6. The decimal's right here. I have one non-zero number in front of the decimal, so that is my answer. I don't have to think about that. All right, coming down to the bottom here. So now we're looking at grouping the like things together. So we have 7 times 2, and then 10 to the 4th times 10 to the 2nd. Remember, we can multiply in any order we want, and that's why we're able to reorganize them. 7 times 2 is 14 times 10. Two bases, two exponents we add. Now again, it's not in scientific notation. The decimal point is right there. I need it to be here. So I need to move it to the left one time. So I don't remember what to do. But if I go back and look, it says if I move it to the left, I am looking at positive exponent. So it means I'm adding that one on. So 10 to the 7th power.